Love Pydantic AI, but wish it wasn't just for Python? Or maybe there's that one missing feature you really want. Or maybe you just don't like being locked into someone else's vision so early in the game that it limits what you can build. Well, today we're diving into what it takes to build an agentic framework from scratch. What features should you prioritize? And most importantly, how do you make sure your system is future-proof no matter what? All right, cool. So like I was saying, since we're actually going to be building an agentic framework, it's important to just, keep in mind what the agent anatomy looks like. Let's just revisit it really quick. So this is what we had seen last time. Now I've made some changes to it. I forgot to update it in the main copy, and the one I was doing earlier just got deleted. But essentially what we discussed in the previous stream was that whenever you're talking agents, it's hard to compare these different agents like Crew AI, Pydantic AI, all those crazy stuff, unless you know what are the different layers when it goes into, building agents. So this is a rough design I have come up with based on my understanding of agents. Let's just walk through it really quick. Okay, at the bottom of the rug, you have the prompting layer. This is the layer actually responsible to talk to the model, interact with the model, do structured responses, and all those kind of things, right? Even if you're thinking tool calls are nothing but structured responses. We'll kind of see it today. So this is one layer, like the prompting layer. This is where a lot of your time in prompt engineering goes, because you want to make sure you have the best system prompt. You want to make sure that, your prompts still work even though your use cases change. So a lot of time in your agentic development lifecycle is going to be spent around this layer, just to make sure your prompts work. But the prompting layer is not reliable. It's going to screw up a lot of times because, hey, agents are not reliable, okay? So we often need some kind of a layer on top of it. And that's where the agentic layer comes in, right? What is the agentic layer responsible for? Well, the most important thing is it implements a reasoning loop. The definition. For me, agents are responsible for a clean and self-contained abstraction for functional logic, for exhibiting behaviors. And essentially, they just have something called a reasoning loop. What that means is an agent responsible to use prompts and, talk to models. And the prompts will give it back structured responses or natural responses. And it can use this to take actions. For example, it can look at the response it gets back and says that, wait a minute, the answer you're giving me is not grounded. Try again. Or it could be like, oh, wait a minute, your structured response, even though the schema is right, it doesn't follow the business rules. It does basic verification, it does things like that. If you're doing some kind of a RAG pipeline, or maybe you're trying to use data contained or rules contained in your database on top of your LLM models, then you'll have to interact with the database before you talk to the model, right? So a lot of the data preparation stuff happens in the agentic layer. You do validation, and of course, like I said, tool calls are nothing but structured responses. So whenever you get a structured response for a tool call, somebody has to call that tool. And again, that's where the agentic layer comes in, right? And of course, an agentic layer is not just talking to prompts. It's also talking to different tools. Like I said, it needs to talk to the external system. So it's going to have a lot of functions and tools. Now, these tools, it would be calling it based on the response it got from a prompt. So maybe the model decides to call a tool, but that's not necessary. The agent can call a tool by itself as well, deterministically. That's completely fine. Now, originally I had orchestration layer on top, but I have actually changed my mind since then. And we had like a wonderful discussion around this as well. But my new idea is the orchestration layer is actually a subset of the agent layer. I don't want to get too much into it today. In fact, we're not going to talk about orchestration at all today. We're not going to be talking about orchestration. Let's not get into that discussion of why the orchestration is down here. Why is it not on top of agents? What even on earth is an orchestration layer? We're not going to worry about it today. But I think it's an important topic enough, or it's a big topic by itself, that it requires its own stream. So just remember this, that prompting and agents are two separate layers. Now, if you come from the Pydantic AI world, right, Pydantic AI merges these two together. The way you write a Pydantic agent, you define your prompts within the agent directly. Let me just give you a quick idea of what I'm talking about. This is a Pydantic agent, probably the only time we're going to be looking at it. But essentially, you see, while defining the agent of a Pydantic agent, you are explicitly going ahead and, specifying a system prompt or a dynamic system prompt for that matter, right? So your prompt layer is very closely bound with your agentic layer, okay? So essentially, Pydantic AI binds these two together, and there is no way of decoupling them, which might be a good thing, might be a bad thing, but I think there are use cases where you want them to be separate, and there are use cases where you probably want them to be together, okay? So the agentic framework, which I'm going to be showing you guys, or my thought process on what an agent should look like, is going to be from that idea that sometimes we need to have the prompting layers separate, but sometimes it's fine to merge them together. I'm still trying to form an opinion around it. Let's just get straight into some code, okay? Let's just get straight into some code. Cool. So agents is already such a huge topic. Even in this stream, I'm not going to be able to fit everything I wanted to talk about, like eventing and all those crazy stuff, which I think is a big part of agents. I'm not able to talk about those things just because I think it's going to be a lot to digest in one video. So we might have to break it down to a third part. Okay, but yep, BAML agents, there we go. So today, we're gonna be building agents with BAML. If you don't know what BAML is, don't worry, we'll just do a quick overview today. But it's essentially one of the tools which sits at the prompting layer. It's not an agentic framework, it's a tool which sits at the prompting layer, okay? And with this project, we're gonna introduce a new agentic framework. An agentic framework we have built in-house, okay? And this is a not over-engineered and probably erroneous agents, okay? That's the name. And yeah, it stands for Nope Agents. It's Nope Agents. That's what we're gonna call it, guys. It's Nope Agents. And okay, just to be clear, I have put in a lot of thoughts for this agentic framework, okay? It's not a fun thing. It's serious stuff. And I think the word Nope Agents really highlights my motto with this agentic framework, okay? Like for example, if you ask me, is this the best agentic framework? Nope. If you ask me to add another feature, nope. Should you use it? Nope. Okay, it's just a fun thing, okay? This is not meant to be like a production-ready agentic framework, okay? It's just to demonstrate ideas. Please don't go ahead and use this, okay? Please don't. Nope. I mean, it's in the name. It's in the frigging name. Please don't use it. Nope, okay? And it's written in TypeScript because I'm so sick of Python that I just want to get away from Python. Oh, one important thing before we start, I have to say this. You know, jokes aside, I have to give a huge shout out to all the builders on Discord. You guys are awesome. I don't think this stream would have been possible without the builders meet and the discussions that we've been having on Discord. So it has been a complete godsend, and everybody has contributed towards building this in terms of ideas. And the contribution of discussion, the contribution of ideas is what the LLM or the agentic space needs right now. I'm really appreciative. Thank you guys. I appreciate it. Okay, cool. Let's look at some code. I'm just going on and on without showing you some code. You guys are getting restless, aren't you? Hey, curious monkey. I'm as curious as you are. Okay, you know what? Let's just touch base on BAML really quick, but we won't spend too much time there. So BAML is sitting on the prompting layer of our stack. So BAML is sitting here, okay? Right now, in its current state, its only job in life is to interact with LLMs and primarily deal with structured responses. I mean, it does a little bit more. It's more nuanced, and it does it really well, and we'll look at those things. But the scope of BAML is not the agentic layer. So it's not going to go ahead and call a tool for you. Because remember, that's the agentic layer, right? It's just going to go ahead and talk to your models and give you back structured responses. That's pretty much it. So how does it work? A really quick walkthrough. So in BAML, you essentially define functions. This is a simple BAML function, okay? It looks like JavaScript. I think they are heavily inspired by JavaScript and a little bit of Python, kind of mix of a lot of different worlds here. But it's essentially a function, right? So I'm writing a simple function. And what am I doing here? I'm taking a parameter and I'm returning a string. So I'm taking a string parameter and I'm returning a string. And my client is going to be Llama 3.18 billion. So that's the model I'm interacting with. Next, I provided a prompt. So clearly this looks like the system message of the prompt. But you notice here, role user. So it seems like this is going to be the user message of the prompt. So we have the system message and we have the user message. Sweet. And anything that goes within these double quotes is actually a Ginger template. So whatever you could do in Ginger, most of it, you should be able to do it in BAML as well. So essentially you're templating out prompts. Nothing too fancy, right? Pretty straightforward. Now, they have really made it their mission to make sure they do this really, really well. Okay? They're not kidding around. They're really serious about this shit, guys. So what it also does is it's gone ahead and tried to make the experience of creating these prompts and testing these prompts a real breeze to work with. So for example, you see a system prompt, shows up right here. You see a user prompt, shows up right here. But it's also going ahead and highlighting the templated part, like the dynamic bits and pieces. So this part, which we inject in here, is highlighted for us. Pretty cool, right? And of course, I can just go ahead and run this, and then it will go ahead and give me back a response. Sweet. Sounds good. Now I can also write in tests. So for example, you see I've written in this one test. What's the capital of France? And that shows up here. Of course, I can go ahead and duplicate this. So let's see if I want another test, I'll call it test 2. And instead of France, we're going to call it, I don't know, Canada. So now I have 2 samples here, right? The first one was France. The second one was Canada. And of course, I can go ahead and run all of these tests. So whenever I make changes to my prompt, I have a quick and easy way to make sure that the prompt works against some of my test cases. Now, it's hard to make this a very exhaustive series of test cases, right? It really helps for a lot of different things, at least so that you know that the changes you're making is not going to severely break something. I think it's a good thing. Okay, cool. So as the Boundary CEO puts it, anything that touches the LLM goes through BAML. Yep, precisely. I think it's a very accurate description. Anything that touches the LLM goes through BAML, right? But yeah, BAML is a prompting layer. That's what it does. Now, this is not cool because this is not the final code that we want to write. All right, our final code is going to be in Python. Please, no Python. I regret saying that already. No Python, no Python, okay? It's going to be in TypeScript. So how does it look like in TypeScript? Let's just check out our file really quick and see what happens here. Yep, there we go. So this is how you would use BAML in TypeScript. So because BAML is a custom language, you have to auto-generate the client, which it does automatically. So I'm not sure if you noticed, but if I come in here and I press Control S, you see this? Whenever I save anything on the BAML file, it says BAML client generated. So there's some code being generated out, and I can even show it to you really quick. The BAML code is right here. Yeah, it generates out a client for us dynamically. We don't really need to get into it. Not important. What is important is this is the client we get out of it. And remember, our prompt was called QA simple. It took a string request. This also takes a string request. It gives me back a string output. This will give a string output back as well. This is BAML code. You just use it in your language, just the way you want to do it, right? Totally up to you. And now BAML has no opinion on how do you use or where do you use this function. You can do it anywhere you want, okay? You're going to see some things going on in this code though. And let's dissect it because that's where the NOPE agent comes in. So NOPE agents is an agentic layer which allows you to do some of the agentic stuff, but it comes with certain mindsets or certain guardrails. It comes with a North Star, right? And that North Star is don't overlap on the functionality given by others, okay? Nope tries to be just this layer. It's gonna try and stay away from this. It's gonna try and stay away from this. It's gonna try and stay away from this, right? But of course, there's always gonna be some overlap. But the core idea of a NOPE agent is you create a function, okay? So I'm calling this function run. Ignore the first argument for now. Just ignore this context argument for now. My run function always takes an argument, okay? So my argument in this case is just a string parameter, okay? And my function always gives back a response. And you notice the response I'm giving back is going to be a NOPE agent response, which is containing data of type string. So essentially, whatever data you want to return back, you can just return it back, just wrap it in this agent response layer. If you ask me, hey, Nurain, why do you have this context object? And why do you have this agent response object? Let's not talk about it right now, okay? Once we get into the meat of things, we'll understand it more better. I'm just introducing you to the NOPE agent framework, just so that you can understand the syntax a little bit better. Okay, so once you have the run function, what do? You simply create a NOPE agent and you pass the run function to it. And just like Pydantic, all the types get automatically defined, which means that whenever you do an agent dot run on this agent, it's always going to take a request of type string just because a query was of type string. So if my query was of type number, and if you go back to run over here, you see request has become a number. So all the type benefits which we had from Pydantic, they all apply here. And these are not just type hints. They're actually type validations going on under the hood. Okay. So yeah, you get all those types, you get the cool stuff. And because I'm returning back an object of agent string, I mean, basically my agent response has a string. The response I get back from my agent will also be a string. So basically this data is string. Pretty straightforward, right? Nothing fancy. It's very similar to PydanticAI. Actually, huge inspiration from PydanticAI, but there are some fundamental differences. And actually that's going to highlight the biggest point of what I'm going to do. Your code looks very similar to Pydantic. Yes, but there's one stark difference. In Pydantic, let me go back to, the little code which we saw earlier. Task summarizer, that's the easiest one. In PydanticAI, your system prompt is a part of the agent. There is no escape hatch. PydanticAI has a strict opinion on how you interact with a model, and it's through its own class, right? This OpenAI model. So if you want to talk to OpenAI, you have to, import the OpenAI model from PydanticAI and then talk to it through that. There is no way you can replace the prompting layer. Okay. The code here, on the other hand, is giving you this escape hatch. So this run function, that's the escape hatch. You can technically call LangChain in here. You could use L in here. I am using BAML in here. But the point is, Nope agents allows you to override the prompting layer and take control of the prompting layer whenever necessary. Okay. That's one of its core tenets. Now, this is such a pathetic use case that you probably don't even need to use Nope agents, because you're just doing a simple prompt, a simple string in and a string out. That's pretty stupid. So yeah, for such use cases, you don't need Nope agents at all. You don't need any agents at all. Like, what are you doing? This is just a prompt. Why go through the overhead of agents? But because I have another rule which says that, okay, if you're doing anything with LLMs, just wrap it as an agent so that the caller knows what's happening. Whenever you're talking to an LLM, in my code base, you'll always see this line, agent.run, right? And it's all typed. So it's going to take the right type parameter. It's going to give me the right type response. The caller of these things doesn't have to worry about whether an agent was using L under the hood, whether it was using BAML under the hood, whether it was using something else under the hood. It doesn't matter. The caller of the agent just calls it as if it's a normal agent, just agent.run. Whatever it does under the hood, it's hidden from the user. So technically speaking, the run function and the main function would be in separate files. So whatever you see here, this would be a separate file written by a separate guy, and this part would be written by a separate guy. So this is the consumer of the agent, and this is the creator of the agent. Does that make sense? I just want to make sure that you're comfortable with the syntax of Nope. We're just getting started, guys. This is like a brief intro to BAML and Nope agents. Cool. Okay, let's move on. So let's take a slightly more different example, especially an example where BAML starts to annoy me a little bit. So the next example is a chat app. So we just saw simple prompts so far, right? We just saw like string message in, a string message out. But what if you want to have conversations? A lot of agents are conversational, as in you can chat with them, right? Like, hey, you do this, but it doesn't give me the best answer in the first response. So you have to like give it back some feedback and make it try again. That's a chat conversation. BAML has no opinion on this. So the way you do such things in BAML is you use Ginger. So what I can do is I can create templates, essentially. This is just a Ginger template. And what this Ginger template does is it takes an array of messages. A message is nothing but an object with a role and a message. Should have been content, but who cares? And what it's doing is it's just looping over each message. It's adding this role, because remember, in BAML, you put roles, in this way. And then after that role, you put a message. So if there were 10 messages with 10 different roles, you would have a role, the message, and then you would loop back and you would get another role. So that would create an array of messages. A little counterintuitive to think of when you think of it initially, but that's just how you do these things in BAML apparently. So slightly counterintuitive. And yes, you'll have to, anytime you want to implement conversational histories, you'll have to start doing things like this every single time. And you're going to see a lot of this piece of code. It's a little annoying. I'm not going to lie. So let's open the BAML playground again. You can see that my system prompt is hard-coded. Whatever you put in by default is the system prompt. You can change that behavior if you want. I don't want to. I like my system prompts. So my system prompt, and because I have an array of messages going here, first is the user, second is the assistant, third is the user, we see our prompt getting generated dynamically. So we have our user, we have our assistant, and we have a user, right? So we just formed a chat history. And this time, even though my last prompt was just tell me something about it, it's not talking about the subject at all. But because it's a chat history, the model figures out that, okay, we're probably talking about Paris, and it goes ahead and describes Paris. If you're wondering why I use Paris so much as my example, it's because Cursor seems to love Paris for whatever reason. Every time it auto-generates my messages, it has to shove in a Paris in there. So you know what? Paris it is. Yep. Makes sense? Pretty straightforward. If you want to deal with message histories, and you're going to do that a lot in agents, because like I said, a lot of agents required conversational histories. We're going to look at that example a lot. You have to do it yourself. You have to like get into this print messages territory, and it kind of gets a little annoying. But it's still a better experience than PydanticAI. So yeah, that's how you do it in BAML. Now, if you say, how do you write this in your TypeScript code? Again, very straightforward. You probably don't need agents here. But now I have a run function which takes an array of messages instead. As simple as that, okay? Currently, Nope agents do not have support for storing messages within the agent. I'm gonna add that soon, but I just don't think it's that big a deal that, you know, the agent needs to store a message history. I mean, I can add that feature in the future if I really need it, but for now, my messages array, I'm fine if it stays outside. But okay, what am I doing? I'm getting a messages array instead of a string this time. So even though I get a messages array, I'm still responding back with a string. And then I make a messages array right here. So I'm creating my Nope agent with the run function. I'm creating a messages array, which is empty. And then in an infinite while loop, I ask the user for a question. I push that user's question into the messages array. I run my agent, get a response back, and then push the response back into the messages array. And that's how I maintain my messages array. Let's run this. Let's see it in action. Oh, sorry. My terminal is on the wrong screen. I didn't realize that. My bad. Let me zoom this up. Okay, cool. So, clear. Yeah. So how would this look like? PNPM run 01B, right? So put in our first question. Add 1 plus 1. So our answer is 2. Cool. Now my second question. Now multiply it by 4. So I'm not saying multiply what by 4. I'm just giving it a message. But you see what BAML is doing under the hood, right? In the first message, BAML just sent in this system message and this user message. That's it. You just see a system message and a user message. And you see the LLM's response back, okay? And that's what we got back, right? Remember, in our for loop, we are appending to that messages array. So the second message adds 2 more messages. One is the response I received by the previous prompt. So the answer is 2. I just took it and put it right here. I'm not even going to worry about parsing it out or doing anything of that nature. LLMs are smart enough to figure out that context. I don't really need to extract these answers. I can just pass it as a message and let the LLM worry about figuring out its importance. And obviously my final question comes here. Now multiply it by 4. And the LLM gives me this response and I see it back here. Make sense? Oh, actually, before we proceed, I want to say why I did not include messages array inside the scope of an agent. Because right now it seems like it's a no-brainer, right? Whatever response you get back from the agent, you're just shoving that back into the messages array. So you're taking the user's message, shoving it in the user's message. You're taking in the response from the LLM and shoving it back in the messages array. So it seems like we're just shoving things in the messages array in a very dumb manner without looking at it. That's not always true. Towards the end of the stream, I'll show you one example where you wouldn't want to do this. You wouldn't want to take like a response you get from an LLM and just shove it in your conversation history. The point I'm trying to highlight is the conversation history is very use case specific. It's not always going to be as straightforward as this. I have one example where, you know, I actually take control of the conversation history myself. But the point I want to highlight is adding a message array or a conversation history to an agent layer, whichever agentic framework does it. I honestly, you know what, I'm not going to talk about them, but I do want to highlight this, that your messages array is not always dumb. Sometimes you want to keep control of the messages array and control what goes in what message, you know? Yeah, you have to be careful about those things sometimes. And that's why currently Nope has no opinions around how to handle messages array. It allows you to do it. Okay, cool. Let's look at the next example. And the next example is structured responses. Now this is where things will start getting interesting. Okay. Okay, cool. So BAML also supports structured responses. So like we were returning string responses earlier, BAML also allows me to return structured responses. So for example, I have an intent classifier. Fans of this channel know exactly how I use it. We have a task management app, and the first step to every statement made by the user is to understand what the user is trying to do. Is the user trying to add a task? Is the user trying to list task? Is the user trying to mark a task as done? Or is the user just talking crap? Hey, you never know. Users like me, they talk a lot of crap. So the first step was just to identify the intent, because our workflow changes based on the intent. The way we handle marking a task as done is very different than just adding a task, right? Those could be different things. So in BAML, again, a very clean way to do this. I have a function, it returns back the class. And notice this class is a union of literals, right? So the intent is technically a string value, which can only be one of these strings. And the fun thing about BAML is BAML will enforce those limits for you. BAML will actually check the response the LLM is giving us, and it will make sure that intent is one of these. So it's not just a helper thing. BAML is actually gonna enforce it during its validation phase. So it's pretty cool. It's pretty cool. All right, cool, awesome. This is my system message, very standard stuff, like an action unknown will be for unknown messages. If the user has done something, then mark the task as done. If the user wants to do something, then they add the task to the list. Then we have this cryptic context output format. Essentially, BAML converts this into a definition language, which is supposedly or allegedly easier for the model to understand. So it doesn't use JSON schema. So it won't convert this into JSON schema like how PydanticAI does this, or even how OpenAI does this, how almost every other tool on the planet does this. It has its own proprietary definition language, which we can have a look at. And finally, these are my system messages. So this is what it did. My system message comes here. Now, this is the output of that context.output format. So this context.output format, it turns out to be this. Now, you see, this is like a custom definition language. It's just saying answer in JSON using this schema, and the schema is like it's an intent with this or this or this. This is a custom definition language. So BAML is not just a language to define your templates in or your prompts in. It's also a definition language or to represent schema, sort of. And I always go ahead and add a little bit of extra stuff. You know, before giving me the JSON answer, just do a little bit of reasoning. Let the model think before it answers. You know, this is just my way of making sure I get a better answer. And the user message goes straight up. User message is, hey, I need to study how to use BAML to build a graph-based knowledge database, because I absolutely want to do that. And now if I run this task, you can see my model is thinking. So it's saying the user starts with I need, mentions study, blah, 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 blah. And the final answer is add tasks, which is right. That was the final answer, right? I do want to add a task because clearly my message is I need to study how to use BAML. So right, it's like a to-do item. So it did classify, it did find the right intent. And even though I'm getting like a string response, just look at this response, guys. This is a string response. I mean, we are not even marking it explicitly where the JSON starts or where does it end. There's no clear indication. BAML is still smart enough to extract the right answer out for us. That is amazing. Guys, this is such a big time saver. And the magic of BAML actually goes beyond this. So for example, if I do this, you know, so let's say I'm saying that don't use the double quote. And by the way, anybody who's not aware, JSON has this little double quote. Not sure if you can see it, but you notice JSON has double quotes. But I explicitly saying that don't use double quotes. Let's see what happens. Double quotes. It did not use double quotes. So this is not even valid JSON at this point. But you see the status? It says passed. Why is that? Because somehow BAML decides that, you know what? It doesn't matter if it's malformed JSON. I'm still gonna make it work. Guys, the beauty of BAML's parser is insane. Even if BAML just did that, I would still use it. That is so good. That is so powerful. Especially because I use 8 billion parameter models. They screw things up all the freaking time. So, you know, having a parsing engine which can work with models is really helpful. So let's look at how does Nope work with this. 0 to A, and let's come over here. Again, very straightforward, nothing fancy. We're just taking in a user message, and for some reason, I go from snake case to camel case. Sure, why not? Let's be a barbarian. And this time, my agent, I'm just calling classify intent simple. I'm giving it that string parameter, and I'm getting a response back, which is of type intent. So BAML actually generated a TypeScript interface for me, which is pretty cool. So anybody calling this agent because of the type system, response.data.intent will always be one of these. It's just good to know. Even when you're typing it, it's just good to know, you know. And yes, those validations are enforced. So it's never going to be anything apart from those 4 keys. It has to be one of those 4 literal values. That's the power of BAML. So again, nothing fancy here. Nope is not really doing anything fancy. In fact, we are just seeing the same Nope code for every single example because literally we're not doing anything. We're just calling BAML and we are just returning a response. But now let's look at a slightly more advanced use case. The thing with structured responses is, guys, that the model will mess around. It's gonna screw up sometime, okay? For example, what if the model gives you back a string value which is none of those 4 literals which we gave it? What if it gives me back a string literal which doesn't exist in my schema? BAML doesn't know how to handle those scenarios. It will throw an exception, right? You need some logic around structured responses to make it a little bit of reliable. And that's where the agentic layer comes in. So let's just look at the raw BAML code of what I'm actually talking about, because this is where we need to start paying attention, guys. This is where the stream really begins. So let's look at my next example. First of all, you'll see that I've made some changes in my classes. Instead of just having one intent and say that, okay, this intent can be one of these types, I'm using something else now. I'm using a lot of classes and I'm saying, BAML, give me a union of these classes, which means the output of this function can be one of these classes. Now, this is very similar to using enumerations in any other language, but this is an enumeration of classes, which you would technically call unions. So this is a union, similar to enumeration. Now, this is an opinion on prompting, okay? This is the only opinion on prompting that I want to share with you guys. What I've noticed is, because of the way BAML works and because BAML is making it so much easier to do structured responses for the model in terms of how it defines the schema and on how it parses it, you can actually push the model to do a little bit more. You can make it work a little bit harder, okay? So what I've done is, instead of having a slightly easier response format, I want to go to 0 to A. So instead of just taking this information, right? This is like just what intent it is. It has no metadata along with it. So it's not that rich with information. But because I know I can do more with a BAML prompt, just because its definition language is so solid and its parsing skills are so solid, I can go an extra step now. And what I can start saying is that, hey, you know what, model? Do a little bit more work for me. So instead of just saying that, okay, the intent is either going to be one of these 4 categories, if the intent was add task, also identify the title for me. If the intent was list task, also identify the filter for me. And the filter can either be done or pending. If the intent was mark as done, then okay, I don't need anything else. And if the intent was unknown, I don't need anything else. So notice my first field in every class is actually a constant value. So intent is either going to be add tasks, it's either going to be list task, it's either going to be one of these 4. Okay, so we just created one quick example. There we go. And this is how it looks like. Now this prompt is going to give you a little bit of a headache, okay? Because it's a complicated schema, guys. But you see, my prompt is essentially, this is my only system message. Now BAML went ahead and created this for me. So you notice, it's saying that give me this object. And because of the description I added to that intent field and that intent field was on top, you notice what's happening here. It's almost like I'm annotating this object. So I'm annotating this object saying that, okay, this object comes in whenever the user wants to do something or add a task to the list. And the intent is add task. And also give me the task title. So intent will be a fixed value. Task title will be a string. That's something the model needs to figure out. Similarly, if the user wanted to list task, then intent needs to be a static value, like a literal value. But filter can be a dynamic value, which the model can figure out. So on and so forth. It made it for me. So it's actually making it easier for the model to understand things. This is my hypothesis, that I think by doing prompts this way, it actually makes it easier for the model to do more complicated things. So earlier, this prompt was done by a Quen model. This is a very stupid model. Now again, to be fair, you would never use an 8 billion parameter model for reasoning, and this requires a fair bit of reasoning. But the fact that you can even get the answer, sort of, right? Sometimes, not at all apparently. Wait, I got like really good answers in my test. Should we add the system rules back? You know what? I'm just going to go ahead and add the system rules back. I think the rules will help it do it a better job. Let's try it out. Sweet. Okay, cool. It works now. So, okay, I needed the system rules apparently. Fair enough. That's fine. It doesn't matter. But the point is, now I'm getting a richer answer. I'm not just getting the intent back. I am also getting metadata for that intent, which goes alongside of it, which helps me do things. It helps me reduce the total number of prompts I have to make in my system, which is really cool. But what if the prompt screws up? What if the model screws up? For example, what you see here on purpose. Now, this is something I've done on purpose. Ideally, you would never do that, but you notice filter. Filter is a string value. So the model can technically put in any value it wants in there. Okay, the model is allowed to put any value it wants in this filter. Okay. I have added a description which says that, okay, you know what, the filter can be done or pending, but I'm not forcing it. So BAML is not really going to do any validation because for BAML, filter is just string. I've done it on purpose. Ideally, you would never do this, but I'm doing it on purpose, okay? What if the model gives me the wrong filter value, okay? In your real world example, often when you have structured responses, there are some business rules which go along with the response. Like you want to make sure that, okay, if one particular field is set, the other field is always set, or you want to run some business rules on your response. Now, it's hard to explain business rules in a stream. I have a simple example here. My business rule is as simple as the filter needs to be either done or pending. Yes, I could have let BAML do this by doing something like this, done, pending, but I don't want to do that on purpose because I want to let the model screw up. Okay, let it screw up because the model will screw up in your real use case as well, right? So, okay, the model can screw up here. The filter needs to be done or pending, but it can screw up. How do you handle that use case? This is how you do it. This is how the code for that would look like. Now, this is a little complicated. Just look at the run function now. Okay, this is where things start getting crazy. So first of all, forget all these loops and things like that. Just look at what I'm doing here. I call my function classify intent and I'm passing it the user's message. And then I check. So if the intent was list tasks and the filter value was not of one of pending or all, then I want it to retry. So I've on purpose in the prompt, I've said that the filter can be done or pending. I think that's what I've done. But in reality, it can only be pending or all, as I'm tricking my model on purpose. I'm trying to confuse it so that it gives me wrong answers. Now, this is the easiest way I could think of increasing the complexity of a task, but you get the point, right? I have played a nasty joke on my model. I am really sorry for that. Yes, I am saying that my filter has to be done or pending over here, but if you go back to my code, I'm saying it has to be pending or all. So obviously, if the model decides to do done, I want it to retry and make sure that it gives me the right answer. So essentially, I need to have a conversation with the model. And this is how you do it. You make an array of messages. Every time you get a response back from the model, you push it to your messages array, right? And here, I am taking that response back and I'm stringifying it. Now, this is that custom logic which I was talking about. Your messages array is not just a dumb array of stuff, right? Here, we are doing some transformation on the response we got earlier. So technically our response was the entire thinking stuff, right? I don't want to put that in my chat history. I just want to take the actual response and I want to add just that stringified version of that response in my message history. I'm running some business rules. I'm checking if my response actually abides by a certain set of rules. In this case, where the filter is one of pending and all. If it doesn't, then I'm pushing another message to my array and I'm saying that, okay, this is a user's message. And I'm saying that, okay, you know what? Filter is required when doing list tasks and it has to be either pending or all. So I'm kind of prompting the model to nudge it into saying that, okay, you gave me some filter value, which is not allowed. Please give me a filter value, which is one of these. So I'm running some business rules based on the business rule which broke. I am going to re-prompt the model and this is how you have to do it. You'll have to implement a for loop. You'll have to maintain a messages array and then you'll have to do all these crazy things. Does that make sense, guys? You see the complication which we're getting into? I don't think you can make any agent which does structured responses without implementing something like this. Because if it's a real world application, I'm sure you have some business rule. Sure, the business rule in this case is stupid, but I'm sure you have some business rule. And if that business rule fails, you have to try again. And forget business rules. What if the model was not able to abide by the schema in the first place? In that case, this would throw an exception. I'm not even handling that scenario. I am not handling the scenario wherein the model doesn't even give me a JSON response or it gives me a malformed JSON response, which even BAML cannot fix. I'm not even handling that scenario yet. So what I'm saying is when you're doing structured responses out there in the open, you're gonna end up using conversations. And that's where this messages array comes into the picture. In my classify intent, I have to take this messages array and I have to make sure that after my user's message, I always add this messages array. Does this make sense? By the way, Pydantic has a very good API to do this. PydanticAI does this really, really well. This is what we saw thus far. Slightly annoying. So yes, this is boilerplate code you have to do every single time. So this is where a lot of the agentic capabilities can help, right? So this is where Nope comes in. So this is the first example where you actually see the benefit of using Nope. So first of all, remember this, the more abstractions you create, the more you have to forfeit flexibility. So the more abstractions you create, the more layers of abstractions you create, the more hard it becomes to keep control of how things are happening under the hood. Now we are creating a higher abstraction, so we're going to lose some flexibility. In fact, we're not going to use BAML anymore. See, no BAML imports here, except this client registry. Ignore this client registry, but for now, just focus on these things, okay? There's no BAML here, we're just using no. So I said I want one of 4 outputs, right? So unfortunately, in TypeScript, there is no way to check types at runtime. Like in Python, the way Pydantic works is that it can actually use those type hints at runtime, because type hints are a first-class concept in Python, right? Unfortunately, in JavaScript, there's no concept of types. So if you make an interface, you cannot really read an interface at runtime. And because of that, we have to use libraries like Zod to define your types. So I know this looks ugly. It would be so much better if you could have done something like this, right? Something like interface, get tasks, then say I have an intent, which is list task, and I filter, which is one of these. So this is so much cleaner, right, guys? Unfortunately, we cannot do this because you cannot use interfaces. You cannot derive type information from interfaces at runtime. One TypeScript problem. Okay, this is just specific to TypeScript. So you have to use something called Zod. So I've done pretty much the same thing. So what have I done here? I'm creating schemas, right? So get task is an object. So I have one key called intent, which is always going to be list tasks. And that describe comes here. Filter, it's going to be a string, and that describe comes here. And this is the name of the type. Similarly, you see it for add tasks as well. Intent is add task. We put the description in here, and we have the title right here. Similarly for mark, task is done. Similarly for unknown task. This is how you describe schemas in TypeScript if you want to use that type information at runtime. This is Zod. This is how you define types in TypeScript using Zod. So you can clearly see what I was doing here. I have a slightly more ugly way of doing it here. Fair enough? Just defining my types. And then over here, I made a union, right? My return type is actually a union of all these types. I've done the same thing here. My final intent is a union of all these types. So I just recreated this using Zod. So yeah, BAML looks nicer, but unfortunately, problem with TypeScript. Can't do anything, guys. We have to do it this way. Now, remember I had a validation logic. This was my validation logic, this if statement. But this if statement is buried inside of these for loops. There should be an easier way to do it. So what I did was I created another function called validate. Again, ignore the context object. We don't care about it. But look at the response. So a validate object is essentially something which runs after BAML gives me back a response. Okay, type of this response is intent schema. So this, okay. I know, again, when using interfaces, it's so much easier. Zod kind of makes things a little bit more difficult to read, I guess. But hey guys, it's not that crazy, okay? We're just saying Zod infer the type of intent schema. That's pretty much all we're saying. So now we have a response, and then I'm saying if the response was not list task, then just return response as is. We don't really care. Otherwise, do that same if condition that we had earlier. But now instead of appending to a messages array or doing any of that crazy stuff, we are saying, nope, we need to retry. And this is our retry message right here. Make sense? So this is my validate function, the same validate function we had, just instead of burying it in the layer of for loops and messages array, we are not doing any of that crap. It's just a stateless function. We get a context object, we get the response back from BAML, we apply whatever rules we want to it, and that's pretty much it. Cool. We have a simple validate function now. Now, because we're not using BAML, I'm doing something which people might not appreciate here. But I'm creating a function which generates a system prompt. So again, I'm taking that context object. Again, don't ask me why this context object is. We'll get to it towards the end. But I'm just returning a system prompt, right? Similarly, I'm also doing a user prompt. So whatever request the agent gives me back, I'm actually templating my own user instruction over here and returning that back. So I'm not asking the user to give me inputs in the best perfect form. I'm like, hey, you know what? You just give me a request. I'll form my instruction myself. Now, again, this is a very stupid instruction. I just wanted to give you an example. Now I have my schemas. I have my validate function. I even have my system prompt and my user prompt. Okay. I don't have my messages array. I don't have any retry logic. I have none of that. Next, I create a nope response schema. I need to tell nope about this response schema. Now, again, this entire concept just exists because TypeScript cannot do type inference at runtime. There's no reflection at runtime for types. And I have to use Zod. So I have to explicitly pass that Zod object to nope somehow. And this is how I do it, right? I just created this structured output object. So from the intent schema, which I want. And then I also passed it a validate function. And I can give it an array of validators. So I can have as many validators as I want. So I'm essentially saying, hey, you know what, nope? This is the response schema I want. So my response should abide by the schema and make sure you run my validators on that schema before giving it back to me. And then finally, I create my agent. But this time I'm not giving it a run function. I'm just giving it my system prompt. I'm giving it middlewares. So my user prompt is actually a middleware. I'm giving it a structured output. And I'm giving it a client registry. Now, this might look very verbose, might not look really cool. You might have a lot of objections to this. I know, I get it. It's not the best experience. Again, it's probably because I'm not the best at TypeScript and I couldn't draft the best experience, but you're letting go of all of this crazy stuff. But you'll be like, Naren, I can just copy paste this, right? No, it's not that simple. Like when you were using BAML, you had to actually jump between these things again and again and again. Okay? You actually had to jump here. You had to make sure all the classes are here. You had to make sure you modify your prompt here, then go back here, then, do things here. So you have to keep jumping between the BAML file and your agentic code, which is kind of annoying because your prompt is very sensitive to the agent code. So every time you want to modify something in your prompt, you have to modify something here as well. It's just very annoying, So you don't have to do any of that. Now all your logic is in one single file. Your system prompt is here, your user prompt is here, your schema is here, and your validators are here. And all you have to do is create a nope agent using the system prompt, using those middlewares, using that structured output, and a client registry. I'll take this moment to quickly go over to PydanticAI and have a look at intent classifier. You'll see the resemblance. You have a system prompt here. You could also put the system prompt elsewhere. So for example, you could have also put the system prompt as a separate function. And again, they have this weird context stuff going on here as well. Very similar to PydanticAI. A system prompt, either you can make it like a string or you could make it like a function. You can do the same with nope agents. Nothing fancy there. And then you can have validators. And the validators gives you the response of the result. So whatever result we get back from the model of type intent, you get it here. And then, you can do whatever type checks you want on that result. And if any type check fails, just raise an exception. And that's pretty much it. What nope does under the hood, let me not explain. Let's just look at it in action. I'm going to say, give me all my done tasks. Now remember, done is not a valid filter. Okay. We have told the model that, hey, reply between done and pending. But in my validation layer, I said that, okay, you know what? You can only use all or pending. So I'm tricking the model on purpose just to make it mess up. Okay, let's just run this. So give me all my done tasks. Done is not allowed. Holy shit, it just gave me the right answer in one shot. We want to run this again. Give me all my done tasks. There we go. So what prompt goes to the model. It's very similar to what we were doing in BAML. In fact, I realized that, when doing structured responses in some cases, I can craft prompt in BAML, but then I can just copy and paste it in my nope agent as a static system prompt because the output is pretty much the same. So what you'll notice is what the nope agent is doing. It's sending a system message, then it's sending a user message. And guess what happened here? We're getting this BAML definition. Wait, nope is using BAML under the hood for you. So using those Zod schema, it actually went ahead and created those BAML definitions for you. So you're still getting all the benefits of BAML. It's just using BAML under the hood. And then the LLM gives us back a response. But like always, because, we have said that, hey, filter can actually be done or pending, the model gives us a reply saying done. But this done is not going to work. So we get an exception. And the exception was invalid filter done. It can be pending or all. So the model goes ahead and tries it again. But see what nope does for me. Nope automatically injects this for me. It automatically injects this where it says that, hey, okay, you responded with this, but the user is giving me back. Okay, so this is what response I got. But the user is saying that, hey, you know what, there's a problem, try again. So we're nudging the model to get a better answer. And now the model goes like, we want a list task, but the filter is invalid. So you mean all? So you know what? We need to use all. And now we got the right answer back. Wait, why is the iterations 1? The iterations should be 2. You know what? It doesn't matter. The iterations is wrong. It's clearly 2 iterations. I don't know why it's saying 1. It doesn't matter. It's fine. But you see what happened? That entire for loop or maintaining that messages array, or nudging the model to get the perfect answer, all that is abstracted away from you, similar to what Pydantic does. All you have to focus on is creating the perfect system prompt and creating the user prompt, which is not that hard if you ask me. It's just system prompt and user prompt, and then you have to define your schema. That's pretty much it. I'm gonna stop here. This might be a little heavy, guys. Does it make sense? Now, one thing I wanna highlight is you can do whatever you want in your validation loops. So in this validation, you could have static business logic. You could technically even call another agent. This is just an async function, right? You could technically even call another agent and, do a groundedness check. You can do whatever you want in that validation function. Okay. Nobody's going to stop you. It's totally up to you. Do whatever you want. Okay. Yeah. That's an important point I want to call out, but this is a massive compromise on flexibility. Like, I don't get BAML's layers or the cool playground when using this approach, I'm back to my PydanticAI ways. The last thing I want to show you guys is tool calls. Okay. Tool calls are nothing but structured responses plus actually calling out a function. That's pretty much all it is. So I have an example here. Ooh, and we'll make it quick. So here I have another function, like another BAML function. It does structured responses again. So you see add task, get tasks, mark a task as done. These are your different classes. I mean, this is how I usually used to do it as well, right? I mean, I think you guys know this, right? We already spoke about this, the unions. So yeah, just doing a very simple structured response here, nothing fancy. And then you open your playground. Yeah, there you go. My system message here, my user message is right here. And if I run this, just give it a second. And it says that that tool which needs to be called is get tasks. And the parameter I need to pass to it is filter. Fair enough. Pretty straightforward, man. Nothing fancy. How would you create like a tool calling layer on top? Now again, let's do it using the raw function, right? So obviously you would first call your prompt to get that structured output. Then you would do a switch case on that tool. If it was get tasks, then you would call the right function, like I'm calling the right function here. And if the filter was something else, I would do something else. The point is, you would do a switch case on the tool, and then you would use the parameters to call that function. As simple as that, right? That's your run function. There's nothing fancy. Now, the next thing I want to talk about is this is not how you're going to do tool calling in the real world. You're never just going to be like, oh, let's call a prompt and do a switch case and call things. It's never that simple. There's a lot more that goes to it. And yes, we can have goof ups here as well. So let's just look at the actual example. Again, we have the same structured response here, but I'm taking an array of messages as well now. Okay? Because remember, the model could screw up with calling the tools and things like that. Don't forget that. The model can always screw up calling the right tool. So you need that retry logic to be there. And it's very important. And if you wanted to implement it yourself, yes, you would have to implement that messages array all over again. You would have to implement these retries all over again. Then you would call your prompt. You would have to push, the user's response to your messages array. Then you would do your validation checks. Once the validation check, if all the validation check passes, then you go ahead and call the tool. So you have to do a lot of validations before you can actually even call the tool or something like that. Make sense? Something like that. So it's very similar to what we did in structured responses, but the only additional step is like you actually have to go ahead and call the tool now. So that's an extra layer we have to take care of. Actually, it's a little bit more than that. Let's be honest. The reason I say that is because while calling the tool, you might get an exception and you want the model to deal with that exception. There could be so many things that could go wrong when calling a tool. The point is your retry logic will have to be a little bit more complicated than what I've shown here. Make sense? So again, this is not complete. It doesn't take care of the exceptions here. This is not a complete example. But yeah, these are the complications. Cool. Okay, you know what? Let's look at the Nope way of doing this now. So again, Nope still uses BAML under the hood. So technically, Nope could be a reference architecture for BAML agents. If BAML ever builds agents, I don't know, maybe they can use this as a reference architecture. I don't know if they will, but of course, apart from the system and user prompt, I mean, I had to do this because, that I had no other option. But yeah, the idea is pretty straightforward. One second, let me remove all the crap. So again, we want to do tool calls now. Our system prompt goes in here. Our user prompt goes in here. Because this is TypeScript, you have to use Zord. So this is my description for my tool. So for the get task tool, I want a filter, which can either be done or pending. So I'm fooling the model again. And then I create a function, which again starts with the context object. And now you will start seeing the magic of the context object. Anybody who's seen my PydanticAI stream, you know why I love the context object. It's for dependency injection. But okay, I take my arguments here. My arguments is of type this, so it will have filter. And then in my function, I just go ahead and say that, okay, I'm putting in my business rules that if the argument I got back was not one of these, raise an exception. Again, you could have called a database function that could have raised an exception as well. So essentially, whenever anything goes wrong, just raise this exception and Nope will automatically retry things for you under the hood. This is exactly how PydanticAI works, guys. Okay. And then I call my tools. As simple as that. And then obviously I have a little wrapper to make a tool out of the function and the schema. So you can just do this. Once that has been taken care of, all you need to do next is, oh, this is the other tool. This is the second tool. So I'm adding the second tool as well. Cool. I'm adding two tools. Fair enough. And now I make the agent. So while making the agent, again, I add the system message to it. I can add some middlewares, which is just processing the request. And then I can add a client registry, and then I can add my tools as well, like an array. As simple as that. Now, this experience can be made better. I'm not saying this is the best way to do it. I honestly don't care. Don't use Nope, guys. It's just reference. It's not supposed to be an actual framework. But yeah, I can ask the prompt from the user, but using it becomes really easy. All you need to do is an agent.run. You pass in that message. And don't worry, even if the user doesn't give you all the instructions, never forget that this middleware gets invoked. So this request is the user's request, and you transform it to add your instructions to it, And that is the user prompt which finally goes to the model then. And you can chain your middlewares, right? So the switch cases of, calling the right tool at the right time, the auto retry logic, maintaining that chat history, all of that is taken care of by Nope. You don't really have to worry about any of that crap. But because I'm reading my tasks from a database, I need to give it a user ID. Now, this is one of my best examples, but, let your imagination go wild here. Whenever I want to call my database, I need to give it a user ID. Okay? Similar to PydanticAI, Nope supports dependency injection. So you can add dependencies. In my case, my dependency is just a string. I want to keep it simple. So it's just a string, which is my user ID. And that is not a parameter to the model. Okay? Actually, let's look at add task tool. That's a simpler one, right? So it's not going to come in args. Instead, it's going to come in context. So what I can do is I can call my database function and I can give it the user ID through args.context.depth. So essentially, I'm essentially doing this. So instead of leaking my user ID to my model, I can pass it in my context object. And this context object is powerful. Because what you can do with dependency injection is you could have made this an object, and this object could not only take simple strings or objects, you can even give it like a complete agent. So if you had like a validation webhook somewhere, you don't have to hard code which agent to use. While invoking the run, the user can dynamically pass in a dependency, which is going to be a reflection agent, which gets used in your validation hook, right? So this dependency injection is so powerful. You can pass in database connection. You can pass in other agents. You can do anything crazy. And this helps you pass things around which cannot go through the model. It's a direct shortcut to, come here. Now, sure, you can have implemented all of this yourself when, using run. But I just think dependency injection is really cool. It's a really good feature. We really need it. And like I said, the possibilities are limitless. You could literally pass an agent as a dependency and then use that agent within your validation function or within your tool. You can do that. Nobody's going to stop you from doing it. And yes, all of this is typed. So dependencies is actually a string because I have defined it as a string. So it's not that, if I'm mistyping in the dependency, for example, let's say I forget doing it, I'm going to get an error. Why? Because property dependency is missing. So obviously we are getting all the type benefits. In fact, we go beyond Pydantic to the point where, let's say that one of my agents gives me back a number. Let's say this was a number for whatever reason. Okay, so one tool is giving me a number, the other tool is giving me like a string. The response you get back is a string or a number. It becomes a union by default. So the types are really powerful. The type system works for your requests. It works for your responses, works for everything. So similarly, if in your user prompt, if you ended up returning, something which is not a string, you ended up returning a number instead. I don't know why would you do that, but let's say you ended up doing that, you're getting an error. Why? Because since your request was string, since your original request is string, you have to return a string as well. So again, your user message could be anything. It could be a complex object as well, right? Your user message could be anything. I just have a string in this example. It honestly doesn't matter. You can do anything you want. It's very flexible that way. I think that's pretty much it, guys. Let's look at a quick demo so that everybody has a surety that it indeed works. I'm pretty sure it does, but it's a demo, so things can definitely go wrong. And cool. So let's clear all of this crap out and let's just run 03C. Okay, so let's give it a prompt. Give me all my tasks which are done. Sure, why not? Now BAML is gonna go ahead and make a prompt. There it goes. So you see, nope dynamically added this extra field for us, because technically in our schemas we just put filter or we just put title, right? But we need a field to be able to do some kind of switch cases and stuff like that. So nope allows us to, or rather nope automatically injects this field for us so that it can internally do a switch case. So this is hidden from you. You don't have to worry about it. We get a response back. Of course, we got the wrong filter. Done is not supported. Yeah, that's the past response. And then our tool throws an exception that, hey, you know what? I don't recognize done. Give me all a pending. And automatically my message history is created for me. So I don't have to worry about any of that crap. The assistant is the message which I got from the model previously. So again, I'm not getting the entire response. So I'm not giving it all of this crap. I'm only giving it the relevant information, which is the structured response. And then I'm saying, hey, user, you know what? Whatever task I had in my database. Yay! It's done. Thank you so much for making these streams so awesome and brainstorming with me. We do a lot of such discussions one-on-one. I would love to just have you join our builder meets, Just join the Discord and you'll know what I'm talking about. That's amazing. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bud here on YouTube and hopefully in real life.